back, and today we're going to look at arithmetic sequences in series. Okay, so this is could be considered the easier of the sequences in series, but maybe not. So who knows? So one of the things we're going to see with this is we talked last time about terms, okay, in an earlier video, and when you have terms, okay, these or elements, okay, these are the numbers in a sequence or a series. So, for instance, a to the n is like all of them, but then that comprises all this. A to the 1, a to the 2 in terms of a sequence would be separated by commas, a to the 3 ... and up to a to the n. Okay, however that sequence or series is defined. Well, the thing you're going to find out about this arithmetic sequence and series is they are always have a common difference. Okay, there's a difference between the terms is always the same. So if you took and subtracted the second term from the first, so that would be a2 minus a1, okay, that difference would give you, say, some number, okay? And then if you also did the same thing between the third term and the second, so a to the 3 minus a to the 1, you'd get the same number, okay? The same number. So it's always going to be that way. Whenever you're looking at two terms in the sequence, the next term minus the first term, and this is always something you see in math and science. You know, if you say the delta of something, right? The delta, okay, is the change in, that means change in something, is usually always represented by the final minus the initial, okay? And you saw this in math when you're doing slope, okay? If you're doing slope of something, you're going to say what? The y2 minus y1, okay, over x2 minus x1. You're always seeing that. Well, in a similar way, we're getting, this is kind of an analogy. It's like looking at it as slope, and you're taking the next one over there, and you're getting the same number. So the slope's always the same on a line, okay? So this arithmetic thing is kind of like a line, okay? In that it's not a line. Don't get me wrong. It's a succession of points that would be kind of lined up. All right, that's a better analogy. So a succession of points lined up. Okay, remember we like to think of these sequences as scatter plots more than lines, because they don't have values in between the ends. Okay, so basically, when we look at this formula, we call this difference number is referred to as D typically. Okay, so this number would be D. So if I went on and got a to the 4th, okay, then the difference between a to the 4th or a to the 4th minus a to the 3rd, that would equal D as well. Okay, so in many books, you're going to see things written a little differently. It's going to be like this. You're going to see something written like this: a to the n minus a to the n minus 1. So if I'm at some number here, say if n is 2, okay, then what do we have here? A at 2 minus what? A at 2 minus 1. So this is a at 2 minus what? A at 1. You see? So it's coming up with the same thing, but if you put it in like this, I can get this formula that I'm trying to show you. This would always be equal to your D, okay? So however you want to look at it, the next term minus the first term, or in this case, in this format, okay, showing you, this is actually going to be referred to as a recursive formula. Okay, recursive formula. And recursive is just a fancy way of saying we're determining the next value. Okay, the next value, we're getting the value, but it's based on the previous value. Okay, so that's the wording that they're using in these books is recursive. Recursive formulas always mean I get the next value, but it's based on the previous value. So you see this next value, what you're going to find out is when you see this put into a formula, which I'm going to have here, if I have a to the n equals a to the n minus 1, okay, plus d, all right, this would be a recursive formula, okay? So let me check on that and make sure I'm right here. Recursive formula would be yes. So in other words, whatever this is the previous term. Okay, so whatever the previous term is, I'm adding this what we call common difference. All right, and that's this number that we got here, this d. This is your d, okay? You're adding the d to the previous term to get the next term, okay? So this then is going to be referred to as a recursive formula. Okay, now, why would you say recursive formula when we use other formula would be a general formula that I talked about in previous? So the general formula, okay, doesn't rely, it does not rely on any previous formulas, previous terms. So you're only going to get, when I say I want the some nth term here, I can put it in. I can say I want the 30th term, okay? And if I put it in this general formula, which I'm going to give you the arithmetic general formula, this is the arithmetic recursive formula here, arithmetic recursive formula. Okay, so I would give you this formula here. The a to the n equals a to the 1 plus n minus 1 to the d. Okay, so, well, I know you might say, well, Mr. Lee, you still need the first term. Yes, you need the first term in this one, but that's the way it's done. You got to start somewhere, and then the rest is I just plug in the number. So, but this is referred to as the general formula for arithmetic sequences and series. This is the recursive formula. I'm gonna just take a little heat off you here. We generally don't use the recursive formula. So this is the one you should memorize, as in memorize. All right, so that's the one you need to know, and with the common difference, and you'll be okay. Now, if I wanted the 30th term, and I know the first term, so here's an example. Okay, if I have 4, 6, 8, and 10, that's all right. Now let's see if we have an arithmetic sequence at all. What's the difference between these two? I have plus what? Plus 2. Here I have plus 2, and I have plus 2. So this is telling me, oh, this is my d. d is plus 2. I have a common difference. This is an arithmetic sequence or series. Okay? Now, the first term here, meaning what? That's the a to the 1, which means what? This is a when n equals 1. Okay, so n is 1, n is 2, n is 3, n is 4. Okay, so I want the 30th term, so I would put a to the 30th, and I would jump it into this formula, and I get what? A to the first is 4 plus what? 30 minus 1, n minus 1, and times what? My d, which is 2. So then I would have 30 minus 1, 29, okay, and 29 times 2, what do we got here? 29 times 2, 2 times 9, 18, 2, 4, 5, 58, plus 4, 62. So a to the 30th term would be 62. So these are pretty easy to do. We can take them to new levels and they get a little harder. But in general, this is the form that you're going to see for an arithmetic sequence. And this is the general form. They also call it the explicit form. All right, and got to memorize this one. And these arithmetic sequences and series, they act like lines, like I said, and they generally diverge. And you may say, well, that's a pretty big word. I haven't heard of that. Diverge. Okay, so when we're talking about infinite arithmetic sequences and series, whereas we're going to take this thing out and we're going to keep going until n equals infinity. And if we did that, we would end up with an infinite series, arithmetic series or sequence. Well, they diverge, meaning they don't converge on a value. They just keep going off bigger or small or smaller or what have you. Okay, but they don't converge on a value. So in this case, it would become more negative or become more positive. It wouldn't converge on a value. So no convergence on any number. Okay, so we'll get to that in another video, but in general, this is what these arithmetic sequences look like. Let me give you another example and maybe we'll close the video on that. So here's another one. I'm going to call it some sequence of n, I don't know, and this is given by 3n plus 5. Okay, here's an example. And you say, all right, what do I got here? All right, what's the first one when n is 1? Well, when n is 1, I get 3 times 1 plus 5. So that's 3, 5, that'd be 8, right? N is 2. All right, I get 3 times 2 plus 5. Okay, so I have 6 plus 5 is 11. And n is 3. I have 3 times 3 plus 5, 9, 5, 14. One more. N is 4. 3 times 4 is 12 plus 5 is 17. Okay, now let's look at the differences between these. I get plus 3. I'm adding plus 3 to each time. So there's my D. Okay, so my D is plus 3. All right, so if I wanted to make this into a general form, right? Well, what would I do? Okay, I would put it in this form. S to the n equals what? A to the 1 plus n minus 1 to d, right? So this would be a to the 1. What do I got? 8, because this is my value. This is my asset. I should be using s to the 1. I'm using a to the 1. You get what I mean. They're calling it s. So I put in that number, and then I just leave it generic as n minus 1, and I put in my d, though, which is 3. Okay, so there you go. This is your general or explicit form right here. Okay, so now, what does this even look like? This looks like a line, right? That's like the equation of a line. So you kind of start to see it coming at you, and a line would be what? It's always going to go up the same amount. It has like a slope, right? The 3 is like a slope. So you're seeing it go up and up and up, right? And then what did you get for your d? Your 3, right? So it's kind of popping out at you in that one. That's how you determine it. So I'm going to leave it on that. Well, the last thing, just say that if I wanted the n number here, I could get it. This is your equation, okay? That's the one we want to memorize, okay? This here, the explicit general form. All right, thank you. Have a good day.